In this video, we have a mass here suspended from on a piece of string width from A to B. Now, it doesn't matter whether we move the mass, the length of the string, i.e. from here to here, will remain the same. We're only going to move the mass from this end to this end, but the length of the string remains the same. Now it's possible. Now it's possible to put the forces into a triangle like we've done here. So the red force here, the weight acting downwards, will be this one. The tension will be at alpha degrees to that. Okay, and this will join this one, and this angle here would have to be beta. This angle, the angle here, would be 180 minus alpha minus beta. So this is called a triangle of forces, so you can actually put them in a triangle of forces. Now, to resolve a situation like this, so let's just move it so we can see. If we move this right up to this end, okay, we can see that the T tension in here will be 0, but the tension in here will be the same as the weight at this particular point. Likewise, if we move it to the other way, the tension T1 will be now 1 and T2 will be nothing. There'll be no tension in this bit of the rope. So if we move it to, okay, let's move it to about here. Okay, and we can, to solve a system like this, we can draw in the components of the force here. So this force here will be T1 sine of this angle, i.e. it's opposite it, and this force here will be T2 sine beta, and therefore to resolve horizontally, taking this way to be positive, this to be negative, we're going to have T2 sine beta minus T1 sine alpha will be equal to 0. These would have to balance each other out. Then if we had to resolve vertically, okay, then we're going to have mg acting downwards. Okay, taking away from that will be this one here, which is T1 cos alpha, as you can just about see it here. And then this purple one here will be T2 cos of beta. If we put them both in, we can see both of them. And as this moves from side to side, the components change. Okay, and using this information, it's possible to calculate T1 and T2. So this is some proportion of the actual weight. We'd have to know what the weight is. We know the G is 9.8. And the same here. Okay, so this has been a video to show you what happens when we have a mass suspended from 2 points A and B, in this case, from a beam, if you like, where we keep the length of this string the same. So this angle here in the middle, alpha plus beta, will actually change as we move from one side to the other. Okay, I hope you've understood. The GeoGebra app I will put in the notes of the video. And I thank you very much for watching.